In this video we're going to continue talking about homologous series and carbon chemistry as part of Unit 2, but specifically we're going to focus on the first of a few homologous series that we need to know at National 5 level, and this is called the Alkanes, the Alkane homologous series. So what do we need to know about the Alkanes? Well, they are homologous series, which if you think back to the previous video, meant that they share a general formula and they have similar chemical properties. But more specifically, it's a homologous series of saturated hydrocarbons. So that's a couple of new words here. So what do we mean by that? Well, first off, if something is saturated in chemistry, it means we are talking about compounds that only contain single carbon-to-carbon bonds. So all the bonds that link all the carbons in the molecules of alkanes are all single bonds, which makes it saturated. And that's a little easy way to remember it as well, because they both start with S. So saturated single bonds between all of my carbon atoms. And we're now also talking specifically about compounds called hydrocarbons. Now that's easy enough, because all that means is it's a compound containing only hydrogen, which is where the hydro part comes from, and carbon, which is where the carbon part comes from. So hydrocarbon, hydrogen, carbon. If it contains any other element, it is not a hydrocarbon. Okay, so a few pieces of information that will help us identify an alkane. So as we looked at in the previous video, I actually gave some examples of some alkane molecules, some alkane compounds, and we noticed that they all ended in ANE, or ane. Now, that's also what the word alkane ends in, so that's a nice way to identify if we have an alkane or not. If it ends in ane, it is an alkane. They also have prefixes to show how many carbons are in each alkane. Now we're going to look at that in detail in a second, but all of those prefixes, in fact the first 8 alkanes, which is the only set that you need to know, you only need to know up to number 8, they're all listed in the data booklet on page 9, so make sure to have a look at that. But we'll come to that in a second. They can also be identified using their name, which we just spoke about, or their full structural formula. Now the full structural formula is when we show all the atoms and all the bonds, which we'll look at in detail in a second. But that is the most useful way to identify members of a homologous series, because that way, as I say, we can see all the bonds and all the atoms. Now why is that important? Because if we're saying that they're all single bonds, we can clearly see that if we see the full structural formula. We can see that they're all single bonds. We can see that it's a saturated compound. So that will be important. And lastly, of course, because it's a homologous series, they will all follow the same general formula. And as we discussed in the previous video, in this case for the alkanes, that general formula is CnH2n plus 2, which we'll now look at in a little bit more detail. So here I've drawn the first few molecules from the alkane family as part of a table. And what I've drawn is their name, so just their simple written name, their word name, the molecular formula, which remember just shows us how many atoms of each element we have in total in the compound, and then this new full structural formula, which shows me all the atoms and all the bonds. So first off, we have methane. And again, easy to spot because it ends in ane. So we know we're dealing with an alkane here. Now this meth part at the start, that's this prefix that I'm talking about. And this is now just something that you're going to have to get familiar with, get used to. If we see meth or meth as a prefix, what that tells us is that there is one single carbon. So we can actually tell quite a lot just from the name itself. But if we want more detail, as I say, this is our best bet, because the full structural formula shows me all the atoms, all the bonds. So clearly we have one carbon, and that carbon is singly bonded, fully saturated, all to hydrogen atoms. It's arranged like this, and it looks like that. Okay, what about the second one? Well, we then have ethane. Again, ends in ane, so we know it's an alkane. Now it has this prefix eth or eth, and that means 2 carbons. Now if we follow our general formula, CnH2n plus 2, we know that if we have 2 carbons, I need to times that number by 2, which is 4, and then add on an extra 2, which is 6, to get my number of hydrogens, which of course happens to be correct at 6. And that's what it looks like there. All the atoms, all the bonds. And this is something that you'd be expected to be able to draw as well. So you might be given the name, or you might be given the molecular formula and have to draw the full structural formula. Or the opposite, where you're given the full structural formula and you might have to name it or give the molecular formula. So we're going to have a practice at that in a second. Next up, and again, all of these are listed as names on page 9 of the data book up to the 8th alkane. But for just now, ends in ane, starts with prop, propane, and this prefix tells us that we need 3 carbons. And again, they're arranged in exactly the same way. All the carbons are singly bonded to each other, fully saturated, and then the rest of the bonds to make up each carbon to have a valency of 4. Remember from the previous video, that is very important. Every carbon has to be bonded to something 4 times for it to be correct. If we do that, we then end up with 8 hydrogens. And that is the 3rd alkane in this homologous series. And the 4th one, we're going to fill in so that we have a practice at drawing them. But we have butane. Again, know it's an alkane, ends in ane, and it starts with but, which tells us we have 4 carbons. So that's what I always do first. I always start out with drawing my carbon chain. And we actually call this the carbon backbone, because it's a bit like the kind of spine of the compound, of the molecule, and it's upon which everything else sits or bonds to. So we draw that out first. Make sure we get the right number of carbons. There's 4, so I do. And then we're talking about alkanes, so they have to be saturated, so they're all single bonds, indicated by this single straight line. And then all I have to do now is make sure each carbon has 4 bonds coming off of it. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And you'll notice it doesn't matter if the carbon is bonding to 3 separate elements and 1 other carbon, or in this case for this carbon here, 2 other carbons and 2 different elements. As long as in total it's got 4 lines coming off of it, that's the correct valency. Now all that's left to do is fill in the number of hydrogens. So we have 10 in this case. And it's very important at National 5 level to make sure that you include all of your hydrogens, because we want to show, again, and I know I'm repeating myself here, but this is very important, all the elements, all the atoms, and all the bonds. We want to show as much information as we can. Okay. Now the series then continues until eventually, and you'll see I've missed some here, we reach the 8th entry, which is the highest one that we need to know about. And it starts with oct, which indicates that it has C8, and then, well, how are we going to figure out how many hydrogens we have? Well, it might be easy to see in your head. You might be able to see that very quickly. If not, if you're dealing with a higher number of carbons and you want to take your time and work it out properly, you could draw it out and then just count them all and add them all on, or we use our general formula to make sure that we're getting the correct answer. So Cn, n in this case is 8, so we substitute 8 for our n here. If we multiply that 8 by 2, we would get 16. And if we add 2 to that 16, we would get 18. So that tells me, using my general formula, I need 18 hydrogens for my 8 carbons to make this an alkane, to make it octane. And if we now take our time and draw that out, I've counted my carbons. I've now got my carbon backbone. Now I just need to make sure I add in the exact number of bonds that I need. To fill in my octane molecule with 18 hydrogens. I need to make sure that I include them all. Now, one last thing that I should say is that you'll notice I have drawn all of these molecules, even though I've skipped a few, in the same way. They're all a straight chain, which means all the carbons are all connected to one another in one straight line. Now, I can tell you that this is not always the case. Sometimes we can have carbons branching off of the main chain. So we can have a chain that basically goes in two directions in terms of the carbons. We will look at that in a future video because that makes things a little bit more complicated, and that means we need some new extra parts for our names to distinguish between those two types of alkane, branched chain and straight chain. But for just now, as long as you know, the alkane homologous series follows the same general formula of CnH2n plus 2, which tells me how many carbons and how many hydrogens I need. If it only contains carbon and hydrogen, that makes the alkanes a hydrocarbon family, and they are all saturated hydrocarbons, which means every carbon in the chain are all bonded to one another through single bonds.